viewers, this is for ABC. On the board we have solutions to simultaneous equations using matrices. I mean, why are we even learning matrices in the first place? It is for us to be able to use it and solve real life problems. And then, of course, we know how important simultaneous equations is in the business field. So matrices helps us to evaluate problems regarding to simultaneous equations. It's actually called linear algebra. Yes, linear algebra. Yes, matrices is a part of linear algebra. Let us go on. Now, how do we use it and solve problems in simultaneous equations or relating to simultaneous equations? There are two approaches. The first one is the determinant approach. Another name for the determinant approach is called Cramer's rule. And the second one is the inverse approach. Okay, so we are going to solve the two questions on the board using the determinant approach. In our next video, we are going to use or make use of the inverse approach. Alright, so for the determinant approach, we use the idea of determinants to solve this. Remember, we are going to have three determinants. We have the delta for the north, or say the main, or the determinant of the main matrix. We are going to have delta x, and we are going to have delta y, because we are solving for x and y. Or you say we are going to have determinant of x, we are going to have the determinant of y, and then the determinant of north. This is what is meant. We are going to have det north, we are going to have det x, and we are going to have det y. Okay, so this det north is actually for this given matrix. For the det x, we are going to get here, and for det y, I will still tell you how it is gotten. And for you to find your x, just divide det x with det north. And for you to get your value of y, divide det y with your det north, and that is all. So we are going to have a matrix here, a matrix here, a matrix here. Whenever you are going to solve this, just write down your det north, det x, and det y. If it is expressed in a and b, just write det north, det a, and then det b. So over to det north. What are we going to do in this given equation? Extract this 6. It is in front of x. So if you bring out 6, you are going to write it here. This 3 is going to be here. This coefficient of x here is going to be 1. And then here is going to be 1. Alright. For the determinant of x, have something have this in mind. The coefficient of x will be missing. You are going to replace it with this. The coefficient of x will be missing here. You will replace it with this one on the right hand side. So instead of writing 6 and 1, we are going to write here 15, 3, and this one 3, 1. Beautiful. So for that y, remember, the coefficient of y will be missing, and it is going to be replaced with 15 and 3. So we are going to have 6 here. We are going to have 1 here. We are going to have 15 and then 3. Okay, so if we resolve this without wasting time, we are going to get 6 minus 3. So we have 6 minus 3, and 6 minus 3 is going to give us 3. If we resolve this, we are going to get 1 times 15 is going to give us 15 minus 3 times 3 is going to give us 9. Okay, so in this case, and of course, if you resolve this, 15 minus 9 is going to give us 6. And here, 3 times 6 is going to give us 18, and then we say 18 minus 1 times 15 is going to give us 15, and this is same as 3. Remember that x is equal to det x over det naught, and y is equal to det y over det naught. So this is going to be det x, as we can see, is equal to 6 divided by det naught, as we can see, is equal to 3. So we have 6 over 3, which is 2. Okay, so for y, we have that y. Our that y is equal to 3. So we have 3 over 3. And 3 over 3 is going to give us what? 3 over 3 is going to give us 1. So in conclusion, the value of x for this first equation is going to be 2. And then y is going to be 1.